Hello, this is Mr. Jackson, and today we're going to talk about looking at circuits in positive physics. So in positive physics, they explain and show circuits in a little bit different way than we do. So I just want to make sure as we go through, you know what to look for and how to answer the questions looking at it from their point of view. So with that in mind, I just want to go to vocabulary and concepts and go through a few basic quick ideas. So in concepts and vocabulary, of course, it starts off with putting certain vocabulary in their own terms, which is just good to practice. There's no reason for me to go through these terms. But as you get deeper and farther into the questions, you begin to see pictures show up. And I want to talk about these pictures really quick and make sure you understand what they're trying to show you. So basically, we know that voltage basically is a push of energy from the battery. And so how does that work? Well, how that works now, from a scientific point of view, we know that it's the electrons that do the moving. But when it comes to circuits and circuit diagramming, they say that everything moves from the positive to the negative. So what happens is whenever you have a battery, and so if we have a battery and you have a positive end and you have a negative end, what happens is there's an imbalance. So at one end you have the positive, so let's just call that here, and what happens is you have a whole bunch of positives, and on the other end you have a connection. If I put a wire from one end to the other, then you have a connection. And at the other end down here, there is depleted or very few positive charges. They're mostly negative, so we don't have very many positives. So this is what causes current to flow. It would flow in this direction from high concentration to low concentration. So this is the direction of flow. And then the greater the discrepancy, the faster the current will flow. So if this was right here, this many pluses and minuses were, let's say 9 volt, let's just say it's a 1.5 volt battery, then that would maybe be the difference between the two sides. But if I'm going to say it's a 9 volt battery, then that means that there are even more positive charges at one end versus the other end, and so electricity is going to be pushed even faster now through this wire. Okay? And so that would have a higher current or a greater current or flow. So the higher the number means the greater difference between the two sides. From high concentration to low concentrations, that's the direction of current. Okay? So what does the green bar means? The green bar in their mind means a resistor. And a resistor can be of 3 different types. You can have a low resistance, okay, or you can have a high resistance, okay. But then they're also going to show you in a different format. They're going to show you it a different way. They're going to show you it with thicker ones, and you're going to be short, and you're going to say, well, gee, that must be higher yet, but it's not. Whenever you're squeezing a bunch of electrons through a tube that's small and thin, they rub and they slow down. Then a longer one, they rub more rather than they can just spread out. So actually, when this is actually thicker than a thinner one, this is even lower yet than that one. So more room, it is easier to pass more electrons through, and it is even lower resistance. So remember that. Short is low resistance, long is higher resistance, but thicker is also lower resistance, okay? So I want to talk about that because that's how resistors work. So guess what? When you're working in a house and you want to put a higher amp circuit in, meaning you want more electricity to flow to a certain room, maybe because you have air conditioners in that room, and it's going to draw more electricity, then we put, instead of 14 amp wire, or we put in 12 amp wire, which is actually thicker wire because it can handle more electricity without getting hotter because it's a lower resistance wire. Okay? So thicker wire actually has less resistance. Okay, and then we're going to get other pictures like this, where there you go, here it is. Which one is, higher and lower resistance? I just helped you out. You have to answer the questions on that. And then you have these ones. Now you have one where you have a resistor, but here you have two resistors in parallel. So you have to think parallel. And here you have two resistors in series. Which one uses more or slows more of the current down? So you still have discrepancies between the two sides, high density and low density. So I just wanted to help you out. So these are all different. Remember, when you have two paths to go through for electricity, that changes it from one path. So think about this. This would be parallel. And what would that do to the resistance? So I'm pretty sure you can figure that out. So let's move on. And so they're going to hear, now they have batteries, okay? But is there, I want to talk about this really quick, battery. Okay, yes, let's just do this. So if I have, do they have ones with higher density and lower densities? Yes, okay, here we go. See in scenario 1, here you have high density on this side, and then you have a lot more positives, and there's not a big difference between those two sides. If that happens, if there's greater amount over here, then there may not be as much push to the other side because there's no reason for the positives to move over here where it's less. Okay, so it's the difference between the two sides that makes a higher current. Okay, so let's go back here. Now we have batteries in different forms, and I want to talk about battery setup. So power and batteries. Batteries are put into a lot of toys in a lot of different ways. How would you make two small batteries stronger by putting them together? Well, if you want batteries to be stronger, then you would put them in series. Okay? That means that whenever you have batteries that flow one after another, like so, that means if you have a 1.5 volt battery and 1.5 volt battery and they're connected in this series like this, you actually are putting in there a 3.0 volt battery. Okay, so anytime batteries are in series, they are stronger. Okay, well then why would we ever want a set of batteries in parallel? Well, the reason why you put batteries in parallel is not to make them stronger, but to last longer. Okay, so if I took a pair of batteries and I did this, so I have a 1.5 volt battery and then I have another 1.5 volt battery, and we hooked them together and then ran them around a circuit, and there was a resistor somewhere in there, then this voltage that's going around would be 1.5 volts, but it would last much longer than this one would. So this one would push faster, but then it'd be used up quickly. So sometimes some toys or machinery or whatever, batteries are put in parallel not to get more power out of them. The 1.5 will run the actual resistor. It just they want to run longer. So maybe this would run, maybe 2 or 3 hours versus this one's 1 hour. Okay, that's just an example. So we have parallel is put in there to last longer, but not stronger. And series is stronger, but doesn't last longer. It uses it up quicker. Okay, and then of course they have these pictures over there. And so instead of drawing resistors, which they do in some pictures, I show you right here, so they do have some resistors. Where am I at? Right here. They do draw out resistors, but sometimes they use bulbs, and a bulb is a resistor. And so instead of doing the squiggly line, sometimes they have their little idea of a bulb, but it's just got a resistor up here, and then of course it's surrounded by the light bulb itself. But they're showing you inside it's still a resistor. Okay, so that means a resistor, and of course the V, you guys know, is a voltmeter, and it's measuring a voltage drop. A volt drop. Okay, so I just wanted to make sure I went through different battery setups and different pushes of voltage. So some of these pictures, I just wanted you to look at it from their point of view and what they're trying to tell you. Okay, I think that covers most of the ideas, and they want to know different things. They're going to give you pictures so you know what the other pictures mean. And of course, remember, you know that this is a parallel circuit, so if you have to redraw this one here, you can do that. Okay, so there you go. I just wanted to give you that overview and make sure you guys understand what they're showing you and how they look at circuits. But remember, always remember that when you go back out and you go to the dashboard, if you're not understanding something, you can always watch his videos and he will explain things the way he sees things. And so make sure you understand that. And as you go through a circuit, I want you to understand that, remember, what happens is as it goes through, and if you have a parallel circuit, you can end up having the current can go in either direction. So you have various paths for the current, and that can divide and change around. So like I said, watch their videos as well as this one, and it will help you if you're struggling, okay? So don't forget about Positive Physics videos. But otherwise, you should have no problem completing some of the assignments in here, and I'll give some more helpful hints as we go along. Thank you very much, and have a great day.